Stanford University.
Well, welcome everyone to lecture number 7 of CS193P, fall of 2013-14. Today we're going to talk about input and output, okay? We're going to talk about views, which are rectangular areas on the screen that you can use both to draw custom stuff and to get gestures in from the user, touch gestures, multi-touch. I'm going to have a demo that's going to show you all that. We're going to build a custom view. It's going to have its own custom gestures and all that stuff. It's basically going to draw the cards that we used in Machismo were just really bad, like A clubs. They didn't look like cards, so we're going to actually have a custom view that looks like a card, right? Has the things in the corner and face cards, all that whole business. All right, so a view is of critical importance in iOS. It's right at the heart of all the drawing we do. You've used a ton of views already. Buttons are views, labels are views, okay? It's basically the building block that represents a rectangular area on screen. It defines a coordinate space, okay? A coordinate space you can draw in and a coordinate space that you can get touch events in and understand where they are. It's hierarchical. All right, so you can have views inside views inside views. All right, every view only has one super view, but a given view could have many subviews, and those subviews are just rectangles. They can overlap, whatever. You know, they're not required to somehow be tiled or separate. They're completely free form subviews of a given view. And you can have any number of subviews you want for a given view. The order of the subviews does matter because they can be transparent. We'll talk about that. And one thing that's sometimes a little confusing is you have this rectangular area that's your view, but you can actually draw outside that area, perfectly legal. There is a little switch you can turn on in Xcode or obviously a property in UIView that says clip my subviews. In other words, don't let my subviews draw outside my view's bounds, right? So you can kind of keep things contained if you want. But generally, that's not the default, and generally we don't. There is a UI window class, very unimportant in iOS. You know, if we're on the Mac, UI window would matter. You have a lot of map windows on a desktop. But in iOS, it's all about views. There's only one UI window. It's the one that's containing all the views that are currently on screen. That's why in the last demo, I was able to say if self.view.window, then I knew I was on screen, right? Because that's the only window there is. And so if I am in it, then I'm on screen. So UI window, very unimportant. You don't ever even have to look at the documentation for UI window. UI views are what it's all about. So this hierarchy of views, views inside views, is most often built in Xcode, just by dragging views in. Now, we haven't done a lot of dragging views inside other views, but it's perfectly legal to do that. And you'll see in Xcode sometimes when you drag, it tries to drop it in another view. You might not even want it to, but it tries to. So a lot of it we build graphically. However, we can also build it in code. And we build it in code, build and tear down this view hierarchy in code with these two methods, add subview. Exactly what you would think. It just takes a view and adds it as a subview of some other view. You send that to the view that you want to be the parent view, right? That's the view to which you are adding the subview. On the opposite side, to get a view out of the view hierarchy, you send remove from superview to the view you want to remove, not to its parent. So you don't say remove from superview colon view. You just say to a view that you want out of there, remove yourself from superview. Okay, so it's a little different adding and removing who you ask to do it. Your MVCs, of course, have a view, and that top level view that contains all the views in the view hierarchy for your MVC is the property view in View Controller. So if you look in UI View Controller, there's a property called view. It's a UI view, and if you go in Xcode and right-click on your controller or right-click on the background of your MVC's view, you'll see an outlet, basically. It really is an outlet, this view property, and it points to that top-level view. So that's a good place to start if you want to start adding views in code to your view hierarchy. And of course, when you drag them out in Xcode, that's what you're doing. You're dropping them in, unless you're dropping it on top of another view, you're dropping into that background view, self.view. Okay, self.view, we use that phrase, self.view. Let's put it in self.view. Self.view is that top level UI view. in UIView controller. It's just a plain old UI view. It's not a subclass version. You never subclass that view. It's just kind of a big container view. And that's another thing to know about views, that you don't always subclass them to draw or do touch events. Sometimes they're just boundaries, right? It's just a view, you want to define a coordinate space and you want to put some other views inside of it. Perfectly fine. We do that. So initializing a UI view, a little more common to want to override the designated initializer of a UI view in a subclass. Remember in UI view controller we kind of said, we almost never do that because UI view controllers are almost always coming out of storyboards, so the designated initializer never gets called anyway, so we just do awake from nib, okay? And we never do that init with nib name bundle thing. That's not true in UI view. In UI view, you do more often both need to do something in your initializer and just want to have your initializer around and code in there. So, but when you do it, you want to also do awake from nib. Okay? That's because UI views are equally created, well not equally, but at least they're commonly created both by dragging them into a storyboard, so that would be the awake from nib initialization, and by sending alloc init to them. In other words, in your code, creating a view. So for example, in your homework, you're going to have to do set cards and playing cards for real, not as buttons, but actually drawing them. And you will almost certainly be alloc initting those views because there's not a fixed number of them, so you can't really drag them out in Xcode because they have to come and go. So you'll be doing that. So we do the same kind of thing we did with UI view controller, right, where we have some kind of setup method. You can call that setup thing whatever you want. And then you call it from awake from nib. And then you also call it from UI view's designated initializer, which is called init with frame. And that frame specifies where this view is in its superview's coordinate system. It's the positioning of this view. Okay? So that's what the code would look like, just like that. And you put your initialization code and setup. And we'll do that in the demo, just so you see that. Now, before I can talk more about UI view and drawing there and getting events, we got to define a few types here. One is CG float. This is a floating point number. All floating point numbers that have to do with drawing on the screen or getting touch events or whatever are CG floats. This might be a double, it might be just a regular floating point number, it might be 32 bits, it might be 64 bits, you don't know and you don't care, but you always have to use CG float. Not only using CG float to specify positions on screen and all the things, but if you're going to be multiplying or adding numbers to things that are on screen to recalculate new things, you want to do all of that in the CG float domain. So you're going to have a lot of properties and local variables that are CG floats when you're doing screen stuff, okay? Then there's a C struct called CG point. That has just got two elements in it, X and Y. That's an X and Y position, okay, in the drawing world. And there's CG size, which is just a struct with width and height, which are both CG floats also, and that's just specifying a width and a height. And then there's CG rect, which is a C struct with those other two CG structs in them, CG point and CG size, and that specifies an origin and a width and height for a rectangle. Okay, so you got to know these four. I'm going to refer these left, right, and center. Whenever we're drawing on screen, this is what we're talking about. Okay? The origin of a view's coordinate system for drawing or for handling events is upper left, not lower left, not like Cartesian coordinates. Okay, this is drawing from the upper left. So positive y values are down the screen. Okay, so you can see I put that point up there, 400, 35. That's x and y. X is 400, way over to the right, and 35 is y and positive, so it's down from that origin in the upper left. Okay. The units in all this drawing are points, not pixels. Okay. Probably you already understand why this is, because some devices have lots of pixels, right? I mean, very high density pixels like these retina displays. Other ones, like some of the iPads, older iPhones, they don't have as many, they're not as dense of pixels. Well, if we didn't use points, if we use pixels, then things we drew would be really small if the pixels were small and really big if the pixels were big. So we abstract that away by using points. Okay. How many pixels per point are on the display that your view is in? You can find out by using this UIView property content scale factor. So it would return 2, for example, on a retina display, because there are 2 pixels per point on a retina display, 1 on a non-retina iPad, for example. You know, probably not going to need to use that property in this class this quarter. In previous quarters, we've played around with it, but not this quarter. But more importantly, there are these properties that talk about the position and extent of your drawing system, okay? And it's really important to understand the difference between these properties. First, you have this CGRect property bounds. That is the origin and width and height of the drawing area in your own coordinate system. Your own coordinate system, the coordinate system you are drawing in and handling touch events in, okay? CGRect frame at the bottom there, that is a rectangle that completely contains you in your superview's coordinate system. So you can see how that positions you, right? Because that's in your superview's coordinate system. That's where you are. Okay? Center is just the center of where you are in your superview's coordinate system. There's no property to get your center in your own coordinate system. You just take your balanced out width divided by 2 and height divided by 2, and boom, you're in the middle. Okay? Now, you might think frame and bounds are going to be exactly the same, except for that the frame is going to be in the superview's coordinate system, so the origin might be different, but that's not true, okay? And the reason for that is that views can be rotated, okay? And if a view is rotated, you can see that the rectangle to contain it might be much bigger, right? Because it's a diamond shape that it has to contain, okay? So there's some details on here on this slide. You can look at them at leisure, but the bottom line is understand that frame is a rectangle containing you in your superview's coordinate system. Bounds is the rectangle you use to draw when you're drawing in your own code in your view. It's your coordinate system. Yeah.
When would the origin of bounds not be 0, 0?
When would the origin of bounds not be 0, 0? That's an excellent question. The origin of the bounds, since it's your own coordinate system, is up to your own interpretation. So, for example, scroll view uses the origin to say, where am I looking in the thing I'm scrolling on? That's just the way it defines origin. You can define what you want origin to mean, okay? Because you're going to be asked to draw, and you know your own coordinate systems. You're going to draw whatever you're asked to draw. So it's kind of up to you. 99% of the time, your origin is 0, 0, because it doesn't mean anything for you. It's just the width and height that matter. But that's a very good question. Okay? So again, you can look at this slide to get more detail, but frame and bounds, just want to make sure you understand that. Most often, you create views by dragging them out of the palette in Xcode, and that's like when you're dragging out labels and buttons and scroll views and text views. Those are all views, and so you just create them by dragging them out. And you can even drag out your own custom views, but the way you do that is you drag out a generic view and then go to the identity inspector and change its class. Exactly like how when we drag out a view controller, we have to go change its class to be one of our custom classes, right? Because Xcode obviously doesn't know our custom classes. At least it doesn't know in the kind of runtime way that's happening in a storyboard. So we have to set the thing. So it works exactly the same as setting view controllers. Creating a view in code, in other words, not dragging it in to a storyboard, you just use alloc init with frame or just alloc init. If you do alloc init, that's the same as alloc init with frame CGRect 0, which is a rectangle with origin 0, width and height of 0. Okay? So you can do either one. If you do alloc init, presumably you better set the frame to something so that it knows where to be when it's put into its super view. So here's an example of creating a UI label in code. You see I said UI label init with frame. I gave it a rectangle. That's in the super view's coordinate system. And then I add subview that label to self.view, which is that top level view in my view controller. And so it ended up at 20x and 20y, and it's 50y and 30 high in my MVC's view, right? Now, you wouldn't probably ever create a label like this because you drag them out, but you might create your own custom view like this, right? Okay, so when do I want to create my own custom views? Obviously when I want to draw something custom, not something that a button or a label can draw for me, or when I want to handle special touch events, swipes or pinches or something like that. So the drawing side of this, which we'll talk about first, is really easy. There's one method in UIView called drawRect, and all you have to do is